Hello guys, today I'd like to solve the problem 1 of chapter 1 of Michael Spivak's calculus book. So this one is the 4th edition, so if you see any difference from your book, that may be it. It's a bit lengthy, this first problem 1, so that's why this video is just the first one. It's also the first video that I'm uploading, so it feels kind of awkward. The way I'm pretending to do these videos is I'll explain some things, do some math, and speed up the video if I find it to be necessary. So the first one is pretty straightforward. With a different than 0, ax prove that ax equals a and x equals 1. That's pretty straightforward. So ax equals a. We just multiply both sides by a to the negative 1. So there would be a to the negative 1 ax equals a of a to the negative 1. So here, this is the correct approach. We have to use one of the properties that he talks about in the book is the associative one, and that's just 1 right here, because this property, it's another property that he talks about in the book. Okay, so that would be just 1 times x, everything times 1 is itself, so x equals 1. And that's our answer. We started right here and we ended up right here. So that's the first one. So the second one is also fairly simple. We just prove that this equality is true. The way we do that is that we get this second part, this right hand side, and multiply it using the distributive rule. So that is so we just do something like this. They cancel out right here. X squared minus y squared, and that's it. So next one. So this third one is a bit more complex, but it's fairly simple too. Those first exercises are really simple, just for us to get the hang of it, I presume. So we just add minus y to square both sides. So we have x squared minus y squared equals 0. So this we end up right here, and so we know that is that. So here we have both two cases. We have this case right here and this one. So we have to think about both cases. So if two things multiply are equal to 0, one of them must be equal to 0. So r, in this first case, x plus y is equal to 0, or in the second case, x minus y is equal to 0. Here, x equals to minus y, and here x is equal to y. So that's our answer. So next one, the fourth. So I was just rearranging some things to make it look better. So let's go. This one is proof to x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. That one is also fairly simple, to be honest. I will stop saying that every problem I say the same thing. So here the approach is the same one. We just use the distributive and we get our answer. So just spinning up right here for you guys. I'll just rearrange. So sometimes we'll cancel out. And we'll have, that's ugly. That's bad. X cubed minus y cubed. Another minus right here, y cubed. So that's our answer. So let's go to the next one. So here we'll just have to think about the general case, which is a bit trickier, but we sure can get through it. So just copying it. And here we're going to do the same thing, honestly. Just distributing it and think about what we're going to get. So here, okay, so that's a bit trickier. So we have here on the first one, right here, I put in purple, okay. X times x to n negative 1, okay, n minus 1. So here is going to, if you remember your rules, n minus 1 plus 1, which is x to the n. We can also think this in our case on the first one. Here we have n to n, and here we have 3. So the first one is n, n minus 1, so 2. I hope I don't sound too confusing. So this and the next one and so on and so forth. So let's go. So this was the x part, the x distributive. Now we're going to do the same things with the y, minus y, yeah? So here I'm going to do something that I think is pretty cool. So plus, and the y part are going to be right here. The same thing that if I did, so all the x right here, and I did like plus and this, you got it? So that's the same thing really. So the y part. Here we have x to the n minus 1. So when I multiply by minus y, that will get minus x to the n minus 1 times y. And I hope you can see what we are going to get right here. So just do for the next numbers. So this is what we get. So the terms are going to cancel out. So this one cancel out right here. This term cancel out with something that is right in the middle. This one will cancel out with this right in the middle, and oh, and okay, and this one cancel out right here. So all these terms cancel out, and we get the final thing that is our xn to the yn, y to the n, x to the n. Oh, here's a minus. Sorry about that. So here you're going to end up with x to the n minus y to the n, and that is our answer. Let's do the last one. This one is fairly simple too. It's the same one. It's the same exercise from like the last ones. So just do the rule and that's it. So here we listen to the now the y. These terms right here cancel out. This and this. So and that's ugly. So we end up with x cubed plus y cubed, and that's it. So thank you guys. I'll try uploading more, the next exercise and so on and so forth. So that's it. Thank you.